On this particular problem, we're asked to find the exact values of the remaining 6 circular functions of theta. And we're going to look for the cotangent of theta, which is equal to negative 23. We have that. And then we're going to find the other 5 trig functions by using this information, which says that theta is in quadrant 2. So when I see something like this, the first thing I do is I try to draw the triangle involving cotangent of theta. And I want to make sure that I draw it in quadrant 2. So I'm going to draw that over here, and I'm always going to draw my angle, my terminal side of my angle. So remember that your initial side is going to be along the x-axis, and the terminal side is just going to be an angle in quadrant 2. Now normally we're looking at this value of the angle, but when we're talking about our different trig functions, we're going to be looking at the other angle, the angle that it makes with the x-axis. So we're always going to be looking at this angle that the triangle is going to make with the x-axis. Next thing I want to notice is that remember that cotangent of theta is equal to cosine of theta over the sine of theta. And then with letters we said that that was equal to x over y. Now this is a proportion. So when we're given that cotangent of theta equals negative 23, that's the proportion that we get with x and y. So we can write negative 23 over 1, and in the x direction, and that's where I put it with the x, is negative 23. And in the y direction, we have 1. If we knew our hypotenuse, we could figure out then our cosine thetas and our sine thetas. But before we do that, we can find the tangent function, because the tangent function is the reciprocal function for the cotangent function. So to be able to find tangent, all we need to do is take the reciprocal of cotangent. So we already have, this one was given, this one we are able to find using our reciprocal identities. Next one I'm going to find is I want to look for the sine of theta, and to be able to find the sine of theta I need to remember that that is going to be equal to y over r. So in this problem over here that we are looking at, my diagram, my y is 1. We don't know what my r is, so we're going to need to figure out what r is. Well, r, using the Pythagorean theorem, squared is equal to negative 23 squared plus 1 squared. When we calculate this out, we end up with r squared equals 530. So when I take the square root of both sides, and remember that you have to make sure that you put in, whenever we put in square roots, we want to do the positives and negatives, except that when we're talking about the radius of a triangle here, it's always going to be positive. So r in this problem is equal to the square root of 530. So this side right here is 530. So coming back here then, we know that the sine of theta equals y, which is 1, over the square root of 530. Rationalizing the denominator by multiplying by the square root of 530 gives us the square root of 530 over 530. Once we've figured out sine theta, it's very easy to go ahead and find cosecant theta, because cosecant theta is the reciprocal of sine theta. So looking at what sine theta was before we rationalized the denominator, sine theta was 1 over the square root of 530. Well, if we take the reciprocal of this, it becomes the square root of 530 for cosecant. So we have found cotangent, tangent, sine, cosecant, and then next we're going to find cosine of theta, which is going to be x over r, which in this problem is going to be negative 23 over the square root of 530, which, rationalize the denominator, gives me negative 23 square root of 530 over 530. And then we know that if we have found cosine, that we can find secant theta, because secant theta is the reciprocal identity of cosine of theta. And notice up here, before I rationalize the denominator, it's always good to find the reciprocal, and the reciprocal here is going to be negative the square root of 530 over 23. The next problem we're going to do is very similar. We're still going to find the 6 trigonometric identities that we need to find. And we're going to be given the fact that we have secant theta equal to 2 times the square root of 5. And it's going to tell us that theta is in the between 3 pi over 2 and 2 pi. So the first thing I do is I look at my range for my theta, and I try to figure out, okay, 3 pi over 2 and 2 pi. Well, 2 pi is at the end of the circle, so 3 pi over 2, we're talking in the 4th quadrant. So I always make myself a little note whenever I'm doing this. And I say, okay, we're in the 4th quadrant. I want to make sure that I remember that when I go to draw my circle and my triangle. So I'm going to draw the triangle now. We're going to be in the 4th quadrant. Here's my terminal side. Remember, I always want to make a right angle with the closest positive x-axis. This is going to be theta. And I'm going to come back here to figure out secant theta, and secant theta is the reciprocal for 1 over cosine theta. So I can figure out what cosine theta is just by taking the reciprocal. So cosine theta is the reciprocal of secant theta. Reciprocal of this is 1 over 2 square root of 5. Multiply by the square root of 5, and you end up with the square root of 5 over 10. And that is your cosine theta. I'm going to use that information in my triangle now. Remember that cosine theta is also equal to x over r. Coming into my triangle here, x is going to be the square root of 5, r is going to be 10. To be able to find sine theta, I'm going to need to find the side opposite my angle. So we're going to need to figure out this side over here. To figure out that side over there, I'm going to just go ahead and use our basic Pythagorean theorem. So we know that x squared plus y squared equals r squared. X squared is the square root of 5. Y squared we don't know. And r squared is 10 squared. Then that means that we have square root of 5 squared gives me 5 plus y squared equals 100. Subtract 5 from both sides. Y squared equals 95. Take the square root of both sides, and that gives me y is equal to the square root of 95. So I can go ahead and put that then on the side here that I have missing. This is the square root of 95. And when we're solving for y and x, they can be plus or minus. So this is where it's good to draw your triangles in the correct quadrant, because we know that in the 4th quadrant, y has to be negative. So we have found, or we were given, the secant of theta. We found the cosine of theta. Now we're going to go ahead and find the other 4 trigonometric functions. So the next one we're going to find is the sine of theta. That's equal to y over r, which is negative the square root of 95 over 10. Once we found that, it's easy to find the cosecant of theta because it's the reciprocal, and that's going to be negative 10 over the square root of 95. And then we need to rationalize the denominator, and we end up with negative 10 square root of 95 over 95. And we have a common factor here of 5. So 5 goes into 10, negative 2 times, and 5 goes into 95 19 times. So then simplifying, my cosecant becomes negative 2 square root of 95 over 19. So that's my cosecant. This is my sine. And then the last 2 things we need to find are tangent and cotangent. So tangent theta is y over x, which is going to be negative the square root of 95 over the square root of 5. You have your operations of radicals here. They both have the same index. They both have the same radical. You could write this as the square root of 95 divided by 5. When you simplify that, you end up with negative the square root of 19. And then cotangent is the reciprocal of tangent. So it's going to be 1 over tangent theta. The reciprocal of the square root of negative the square root of 19. 1 over negative the square root of 19. Rationalize your denominator, and you end up with negative the square root of 19 over 19. And that is your cotangent function.